Hello everyone, welcome to the chemistry final exam review that I'm making right now for you. The majority of the review will be based on a particular equation that we'll use. So you may want to write this down now. If you were to have magnesium plus hydrochloric acid and mix them together, you would yield magnesium chloride plus hydrogen as a diatom. Maybe take a minute to write that out and try to write out in the symbol form that equation. I'm going to write it now, so you may want to pause the video and try your best with that. You should have gotten magnesium plus HCl yields MgCl2 plus H2. Fantastic. So we're going to be using this throughout the review video as our staple equation, if you will. I'm going to go one by one on each of the bullet points of the review, and we'll go from there. Bullet point number 1, it says converting grams to moles. All right. So let's pick one of these so we can become familiar with this equation. Let's say magnesium. If I want to convert, let's say I have 3 grams of magnesium and I want to convert that to moles. Well, to do that, I just have to multiply by the molar mass, right? Which in 1 mole of magnesium, how many grams do I have? The molar mass is what's on bottom, and it says 24.3. So I'll do 3 grams of magnesium times 1 mole over 24.3 grams. All right, grams are on opposite sides. I have one on top here, one on bottom. So that unit, grams of Mg, can cancel out. I'm therefore left with moles of Mg. We'll multiply across, so that's going to be 3 times 1 is equal to 3. Mole Mg. What up, G? And I have 24.3 at the bottom, so we'll do 24.3. Alright, so let's see how many moles of magnesium do I have. You should calculate that you have 0.123 moles of Mg. Cool. So basically, when you're converting grams to moles, you need to have the molar mass. All right. Let's now do the next one. That's if I have a single atom of magnesium, Mg. Well, what happens now if I have something like HCl, a compound? So if I were to have, for example, 10 grams of HCl, how many moles is that? Again, you have to multiply it by moles over grams. So in 1 mole of HCl, how many grams do I have? You have to add these together. So this is going to be 1 plus chlorine is 35.45. So we'll just say 35 or 35.5. Why not? It's close enough. That'll be 36.5. If you said 37, it's not the end of the world. So that's 36.5 grams of HCl. Equals, we're going to have 10 over 36.5. This is moles of HCl. Grams HCl cancels with grams HCl. We're left with moles of HCl. So we're going to have 10 divided by 36.5. Which should give you 0.0 274 moles of HCl. And you can try just to make up a problem as you like. It's not that difficult. We've done a lot of this throughout the year. Cool. All right. Next it says convert between atoms and moles. And the next bullet point number, where am I at? Yeah, convert between atoms and moles. The next one says converting between atoms or molecules to grams. All right. So in that case, for bullet points 1 through 3, you really need to make sure that you memorize the upside down triangle thing that we had, where we had mass, which was in grams. Then this beautiful thing popped up for some reason. All right. To moles, to atoms or molecules. You must memorize this, or have had memorized this. This is old news. And to get from moles to atoms or molecules, you need Avogadro's number, which was that 6.022 times 10 to the 23rd. So write that down somewhere. All right. And to give us some extra space, I'm going to erase our equation, even though we're going to continue to refer to it. And in fact, I'm going to write in the corner our little triangle so we can refer to it throughout the problems that we're doing. Okay. Notice you cannot go from atoms to grams directly, or molecules to grams directly. Okay, so let's say we have 2 moles of HCl. And I want to know how many atoms, actually I'll back up, how many molecules. I want to find out how many molecules is that. Well, first, if I'm at moles and I want to go to molecules, I'm starting with moles and I'm going to atoms or molecules. So I have to use Avogadro's number somewhere there. Let's get a different color going on. All right. So I'll start out with 2 moles of HCl. In 1 mole of HCl, how many molecules do I have? In 1 mole of anything, I have 6.022 times 10 to the 23. Molecules of HCl. You should write molecules here. I'm not, because I'm running out of space. So moles of HCl cancel with moles of HCl. This is going to be 2 times 6.022 times 10 to the 23rd. And keep in mind something, that this is going to equal molecules of HCl. Right? So this should give you 1.204 times 10 to the 24 molecules of HCl. Cool. Now let's look at our products for a moment. One of our products in the equation that we're going to be looking at is magnesium chloride. All right, MgCl2. That's one of the products that we have, magnesium chloride. What if I wanted to find out how many atoms of chlorine are in 39 grams of magnesium chloride? So I have 39 grams of magnesium chloride. And my question is, how many atoms of Cl? You can pause here and try it on your own, or you can sit back, relax, and follow along with Mr. Felton. Okay, so I'm going to start out with, I started with grams, and I want to get all the way to atoms. Okay? Before we get to this, though, I want you to notice, when I look at magnesium chloride, how many atoms do I have right here? I have 1 magnesium, and I have 2 chlorine. So total here is 3 atoms. Okay? That's going to be important. How many molecules do I have here? It's actually a compound, but how many compounds or molecules do I have here? I only have 1. So even like H2O or CO2, I might have 1 molecule of H2O, but how many atoms are in 1 molecule of H2O? 3. That's important to keep in mind. Let's look at this now. If I have 39 grams of magnesium chloride, how many atoms of chlorine do I have? So we start out with 39 grams MgCl2. I first have to go from grams to moles. Right? So let's move it to moles. How many grams are in 1 mole of MgCl2? You have to calculate the molar mass. Let's do that. Mg is 24.3. Cl is 35.5, we'll say. And I have 2 of them here. So I have 35.5 plus 35.5. So 24.3 plus 35.5 plus 35.5. Your total should be 95.3. So that means in 1 mole of MgCl2, I have 95.3 grams. Grams of MgCl2 are going to cancel with grams MgCl2. Now I'm at moles. Cool. So I'm at my mole area. So now I need to convert to atoms and molecules using Avogadro's number. But since I'm focusing right now on MgCl2, it's going to be molecules. So in 1 mole of MgCl2, in 1 mole of anything, I have 6.022 times 10 to the 23. In this case, it's going to be molecules. You could write out the full word. I'm only putting molecule. Cool. I need some space to write, so I'm going to erase some of this beautiful stuff. But at this point, you should have it all written down. I'm going to leave this actually for now, because that's important stuff. Cool. So 39 times 1 times 6.022 times 10 to the 23. You're going to multiply across on top. All that divided by 95.3. Cool. That should give you, let's see here, 39 times 6.022 times 1 divided by 95.3. I should get an answer here of 2.46 times 10 to the 23 molecules of MgCl2. I'm not done yet though, because my question is, how many atoms of Cl? Right? How many atoms of Cl? I'm going to erase this for now. To give me a little more space. But how you should have written it out, let me try to rewrite it a little smaller. It would be 39 grams of MgCl2. You would first convert that to moles. So in 1 mole of MgCl2, I had 95, what was it? I erased it. I think it was 95 point something. We'll leave it at that, 95.3, yeah, grams. In 1 mole, I had 6.022 times 10 to the 23 molecules okay, and that's when I finally was able to get this number. I'm going to take it a step further now, though, and I want to now convert molecules to atoms. So in 1 molecule of MgCl2, how many atoms of Cl do I have? 2. So here, molecules of MgCl2 cancel with molecules, and that would be MgCl2. Right? Mole cancels with moles. Grams cancels with grams. I'm left with atoms of Cl. So we already did 39 times 1 times 6.022 times 10 to the 23rd. You could continue and multiply that by 2 because this number's on top. And then divide the whole thing by 95.3. But we've already done, in my calculation thus far, we've already done up to this part. We've done all this. So we can just multiply by 2. So take this, multiply it by 2. Your answer should be 4.92 times 10 to the 23rd atoms of Cl. Gonna double check my math there. Yeah, looks correct. Fantastic. If you look at bullet point number 4 while I erase, here it says calculate the molar mass of atoms, molecules, and compounds. We just did that, calculating the molar mass. Not of atoms, but you do the same thing of cross-multiplying like that using this formula. To convert units. Balancing chemical reactions and determine reactant and product coefficient ratios. We're going to do both of that at the same time. So our reaction in the beginning was Mg plus HCl gives me MgCl2 plus H2. Yeah. So let's balance it. Here I have 1 magnesium in my reactants and 1 magnesium in my products. So that's cool. Here I have 1 hydrogen in my reactants and I have 2 in my products. So automatically I know, hey, I have to multiply this whole thing by 2. Fantastic. By doing that, that just multiplied the chlorine by 2. So now on this side in my reactants, I still have 1 Mg, but now I have 2 hydrogen and 2 chlorine. On my product side now, I still have 1 Mg, 1 magnesium, and I have 2 hydrogen and 2 chlorine. So it looks like we're good to go. That's all it took to balance that equation. The coefficient ratio here is 1, because I have a 1 here, I guess. I told you guys before that if you don't have anything here, it means 1. So we have a 1. Here my coefficient is 2. Here my coefficient is 1. And here, even though it says 2, that's not my coefficient. Alright, this is saying H bonded to H. So I might have 2 hydrogens, but it is not the coefficient. In this case, it's 1. Alright. Just for fun, let's try to do another problem where we can balance an equation, shall we? Let's try this. We'll come back to this equation again, but I just want to give you guys another practice problem for balancing. And at this time, you may want to pause the video, or at least after I give it to you first. And by that, I mean the question. If I were to have, let's see, what's a good one? Okay, here's a good one. If I had Na, sodium, plus H2O, and that gave me NaOH plus H2. Looks pretty good. Well, automatically here I can see there's going to be an issue with hydrogen. On my reactant side, I've got 2 hydrogen, and on my product side, I've got 3. Well, this is a nice even number, 2. 1 I can manipulate easily and try to make other, I can multiply by any number. So I can manipulate a 1 easier than I can manipulate a 2. So let's keep that in mind. First off, we've got 1 sodium, 1 sodium. Fantastic. Here I've got 2 hydrogen, and here I've got again 3. So what can I possibly do? Multiply this by 2. Right. And that now makes me have 2 sodium on my products, so I have to have 2 sodium on this side as well. Looking at this, I have 4 hydrogen on this side now, and only 2 here, so I'll multiply that by 2. That gives me 2 oxygen. On this side I also have 2 oxygen, 2 sodium, and 2 hydrogen plus 2, that's 4. 4 hydrogen. You have to play around with the numbers and make sure you have a pencil anytime you're balancing. What's the coefficient ratio? 2 to 1. Fantastic. Okay, looking back at your review, there it is. Identify reaction types. Combustion, single replacement, double replacement, synthesis, and decomposition. Both of the problems that we've looked at so far, whether it be this one or if we look at the one that we just had, and by the way, these reactants, when you have sodium and you put it in water, it's extremely reactive. So if you want to even look it up online, on YouTube even, just type in sodium into water and you'll see a huge explosion. It's pretty cool. But it's just simply sodium put in water and it reacts. It's very, very reactive. Alright. But if you look at these anyway, they're both different. Right? No, they're not. They're both the same actually. Here I have A, B, C goes to A C plus B, so that's single replacement. And here's A, B, C. I apologize. I told you guys always to look at H2O as H plus and OH minus. Yeah. So we have A, B, and we'll say that's C. So B and C are together here. But now A and C are together here, and B is kicked out. Both of these are single replacements. Some examples of the others would be as follows, and try your best maybe to identify them on your own. If I were to have lithium plus sulfur giving me Li2S, try to identify that. I'm busy right now making a movie for you guys.
It's a movie now.
Yeah, I'm making it now. Yes, no.
Graham Smalls, Mr. Derek Relton.
That's one of our prized students.
My name is Mr. McMahon.
No, it's not.
No, I'm joking.
Do you want to give a shout out to anybody?
I give a shout out to
This is for
Faisal
grade
Mohammed.
11. This is grade 11.
Grade 11?
Yeah.
Shout out to Abdurrahman. I forgot his name. Abdurrahman Khalid.
Me too.
Abdurrahman Ahmed. Khalid Sirbil. Aziz Fahad. Aziz Naif.
Are you naming all of them?
Fawaz Ghalib. Mr. McMahon. My name is Mubarak.
Don't forget Badr and all the other guys and girls. Yeah, okay, thank you. Kids these days. Okay, another example that we have would be if I had H2O going to H2 plus O2. Okay, another example would be I'm trying to find some good examples for you guys other than the ones that we've just looked at. I guess if I had something like Li2SO4 plus HCl, that might work. That would give me lithium chloride plus H2SO4. And finally, number 4, if I had something like C2H plus O2, and that gave me CO2 plus H2O. I think it's pretty simple to look at these and hopefully identify them. The first one is clearly single replacement. And if you wanted to take the, it's not single replacement, I'm sorry, synthesis. If you wanted to take the time to even balance it, you'd have 2 Li there. And maybe even try to find out what is the ratio. So maybe pause the video now, write the first one out. Okay, try maybe putting the names of these down. What do you think the names are? And then come up with the ratio. In this case, it's 2:1:1. Just for extra practice. Here we have H2O, and it seems like it's splitting into H2 and O2. That's decomposition. You can pause the video now and try to balance it, or with me. Looks like this is going to be a 2 to 2 to 1 ratio. This looks like double replacement. We have A, B, C, D. So if you have 4 parts in your reactants, automatically you should know, hey, this is going to be at least double replacement, depending on what it is. Cool, so that's double replacement. If I were to try to balance it, looks like I would have to put a 2 here and a 2 here. So that would be a 1 to 2 to 2 to 1 ratio. Alright, let's get a brighter color going on. And this bottom one here, that's CO2, by the way. That's going to be combustion. A beautiful combustion reaction. If I were to try to balance it, I would say, hey, I've got 2 carbon here. I should make that 2 over here. So now I've got 2 carbon, fantastic. Here now I've got 4 oxygen and 1. So that's a total of 5. But I also have to keep in mind that I've got this 8 over here. That's going to make things a little bit tricky. Alright. Because now if I look over here, even if I multiply this by 4, I'll have 8 oxygen. I guess it doesn't make it tricky. Here I'll have 8 oxygen, I'll have 8 hydrogen, but I have to make the 8. So multiply by 4. And that's it. Does that check out? 2 carbons, 2 carbons. 8 hydrogen, 8 hydrogen. 8 oxygens. That's 4 oxygens plus 4 oxygens. So yeah, it's good. So we have a 1 to 4 to 2 to 4 ratio. And again, that's combustion. So those are the different types of reactions. If we look back at your study guide, the next bullet point is global warming. Just review it. Know what happens, know its causes, know what the effects are of it. Know what types of gases are cause it. What are greenhouse gases? We discussed 3 different types in class. Let's maybe review those, it might be good for you. Next, determine the oxidizing agent and reducing agent in a redox reaction. Determine what is oxidized and what is reduced in a redox reaction. Calculate the oxidation number of a given atom within a compound. Let's do that. Let's go back to our original equation. So we had Mg plus HCl. That gave me magnesium chloride plus H2. Now I've mentioned to you guys before in redox reactions a couple things to keep in mind. First thing is I don't care about balancing. The second thing is to keep in mind this little stepladder thingy. Where this will be a way to tell me if something's reduced or not, if it goes down or if it goes up. So Mg here, it's all low, so that means it has a charge of 0. Here in MgCl2, here I can use my periodic table and say that Mg is plus 2. Or you can say hey, or you don't have to say hey at all, but you can look at this and see that chlorine is minus 1 and I have 2 of them. So this whole thing is going to be minus 2. Alright. Hydrogen over here looks like it has a +1 charge. Chlorine has -1. And this diatom, H2, has a charge of 0. Cool. So magnesium went from 0 to magnesium +2. Chlorine went from -1 to chlorine -1. Please do not say it went to -2. Each one is still Cl -1. You know what I'm saying? And then hydrogen went from +1 to 0. So magnesium went from 0 to +2. So if I went from 0 up to 2, that means it was oxidized. And chlorine, nothing. Hydrogen went from +1 to 0. So in the hydrogen's case, it went from +1 down to 0. So because the hydrogen went down, it was reduced. So these are going to be the 2 that we focus on. Because magnesium was oxidized, that means that it reduced something. What did it reduce? Hydrogen. So magnesium is the reducing agent. And hydrogen was reduced, that means it oxidized something. Therefore it is the oxidizing agent. What did hydrogen oxidize? Magnesium. Magnesium was oxidized. If magnesium is the reducing agent, what did it reduce? Hydrogen. Hydrogen was reduced. Cool. Next one, it says, calculate the oxidation number of a given atom within a compound. Alright, so let's say if we had something like H3PO4, or if you had something like Cr2O7-. Fantastic. So let's look at both of these. In orange. Hydrogen is always going to be +1, right? And oxygen is always -2. If I were to ask you, what is the oxidation number for phosphorus? Here, I would say, okay, well, I've got 3 hydrogens, so that's going to be +3. And oxygen is -2, and I have 4 of them, so that's -8. In the beginning, I don't have a charge. So the charge is 0, that means that it all has to equal 0. So 3 plus something, -8, has to equal 0. Well, the only answer I could possibly have is +5. If you wanted to solve that out a different way, you could say, okay, well, you can move these over on this side of the problem. So if I were to, how do I get rid of -8? By adding 8 to both sides. We'll even put an x here, because we don't know what x, we're going to solve for x. Right? So now we have 3 plus x is equal to 8. -3 minus 3, x is equal to 5. This is where you're doing these problems in math class, where they come in handy for chemistry. And when you learn how to read English, it's all about learning how to read chemistry. And when you learn about history, it's about learning the history of science. See how why all your subjects are important? They're important for this subject right here. All right. Let's do the same thing for dichromate. All right. If I'm looking at dichromate, we're first going to look at, okay, well, chromium, I'm not exactly sure what it is, but oxygen, I know what it is. So, because oxygen is always -2, it's always going to be -2. And in fact, I think this is a -2 charge. But oxygen is always a -2. Chromate, I don't know. That's going to be my X, I guess you could say. But I've got 2 of them. And the overall charge on this is -2. So we're going to have X plus something equals -2. To solve for this space here, that's going to be our oxygen. So that's going to be -2 times 7. The overall charge here is going to be -14. So you can put that in here, -14. How many x's do I have here? I've got 2 of them. So we have 2x minus plus -14, if you will, is equal to -2. To get rid of this, I need to add it to both sides. So plus 14, those cancel, plus 14. 2x is equal to -2 plus 14 equals 12. All right, divided by 2, divided by 2, x equals 6. So the oxidation number for chromium here is 6. But I've got 2 of them, so this is going to give me a positive 12. Cool. I kind of went around on that one to solve it. It's actually easier, I think, just looking at it and trying to use mental math. But if that helps you to solve it that way, you're welcome to. Next it says calculating the molarity of a solution. Calculating the molarity of a solution. The equation for molarity is capital M is equal to, that's molarity, moles over liters. Right? And if I'm given molarity in a question, so if I were to say, if you have 0.2 liters of a solution that is has a concentration of 5 molar, how many moles of HCl are needed to make such a thing? In this case, if I look at my equation, we isolated it before by multiplying both sides by liters to get moles alone. So if I multiply this side by liters, those cancel out. Multiply this by liters, we get liters times molarity is equal to moles. So these are the 2 equations you need to know. Molarity is equal to moles over liters, and liters times molarity is equal to the number of moles. From this, I can calculate how many grams of something I need. So let's try a problem. If I were to say, how many grams of hydrochloric acid do I need? How many grams of hydrochloric acid do I need to make 3 liters of a 5 molar solution? And I want how many grams? right? Hopefully you've written these down. And I'm using HCl because it's part of our master equation for the test, if you will. So what things am I given? I'm given 3 liters. So I can say, and I'm given molarity, and I want to find out how many grams. So I'll use the equation, liters times molarity equals moles. So I have 3 liters times 5 is equal to, well, 3 times 5 is 15 moles. I don't want moles, I want grams, so I have to just convert 15 moles to grams. So 15 moles of HCl times in 1 mole of HCl, right, in 1 mole of HCl. From before I calculated that the molar mass of this is 36.5 grams per mole. So 36.5. Moles of HCl cancels with moles of HCl. That should be grams. So 15 times 36.5 equals, as I got my calculator ready, it equals 547.5. If you round up to 8, that's cool. Grams of HCl. That's how many grams of hydrochloric acid are needed to make 3 liters of a 5 molar solution. Try this one now. How many no, not how many. Erase, yes. What is the molarity of a solution with, let me erase that. What is the molarity of a 200 milliliter solution with 10 grams of magnesium? So write this question out, try to solve it on your own, and maybe pause the video and then you can watch along. You could also sing along. I wouldn't suggest it, but yeah. And I think for now, because this video has been kind of long, I'm going to finish this up and then we can take a break, and I'll make another video on the rest of calculating limiting reagents as well as pH. So for this molarity question, we started with 200 ml and I had 10 grams of magnesium. And my equation is molarity is equal to moles over liters. Cool. I'm given grams so I can figure out moles, and I'm given ml so I can figure out liters. To convert milliliters to liters, I have to divide by 1,000 or multiply by 1 liter is equal to 1,000 milliliters. Those are the same. But to change the unit to liters, I can multiply like this. Milliliters on top cancels with milliliters on the bottom. I'm left with 200 times 1 L. That equals 200 L divided by 1,000. which should give you 0.2 liters. Okay, so I'm done converting that. So now I have 0.2 liters. I've got 10 grams of magnesium. I want to convert that to moles. In 1 mole, I have 24.3 grams. As I multiply across, it's going to be 10 divided by 24.3, which would give me looks like 0.412 moles. So now I can calculate my molarity. Molarity is equal to, you'll do 0.412 divided by 0.2, which should give you a molarity of 2.06. Alright, so again, for the next video, we'll look into identifying limiting reagents and also calculating the amounts of products possible to make based on the amounts of materials given. We'll also calculate percent yields, describe characteristics of acids and bases. What is a hydronium ion and hydroxide ion? Those are pretty easy. Alright, in the next video, make sure you hold on to your notes and this M right here, don't lose that. And that'll be on the second video. As far as describe the components or parts of a solution, the YouTube videos are still up for how to do that, or just look at the definitions that you might have written down. Also the crossword puzzle that we've done in class, if you did it. Those are pretty good to have some examples and how we collaborated as a class. So be on the lookout for video 2. And until then, stay cool. Or whatever it is you do. You know what I'm saying? Study hard. And yeah. Don't forget the MG.